Today we're talking about the real number system and classifying the different types of numbers and what they're called. So a lot of this is just going to be terminology. So I'm going to be referring to this side and to this side for definitions. Okay? So our smallest subset, think about when you were young and the numbers that you started with when you were young. And when you first started learning how to count, what type of numbers did you start learning to count with or count by? You probably counted by one. You took items and you counted 1, 2, 3. So that's what we call our natural numbers. So on the back, we're going to write natural numbers. They're also known as our counting numbers. Whoops, that's a U. So our counting numbers. And that is 1, 2, I'm going to do a bracket here. 1, 2, 3, 4, and they go on and on. Okay? Now, at this point, you're counting numbers. There's no fractions, there's no decimals, and there's no negatives. And notice there's going to be something else in whole numbers that we add to this. So natural numbers are our counting numbers, our 1, 2, 3, 4. Whole numbers. The only difference between natural numbers and whole numbers is one number. And that number, whole numbers are natural numbers, and one other number, and that is 0. So the only difference between these two is the number 0. This is these are called braces. So 0, 1, 2, 3, all the same thing as natural numbers, except for, and now we're adding the number 0. So think of whole, that 0 in or the O in the whole, and think of 0. I don't know, that's the way you can remember it. Okay, now integers. And you've heard this quite a bit about adding integers, subtracting integers, but sometimes we forget what that means. What an integer is are whole numbers and their opposites. So these are whole numbers and their opposites. Which means, like the 3, the opposite of 3, negative 3. The opposite of 224, negative 224. The opposite of negative 8, positive 8. Now, here's the deal. 0 is an integer, because by definition, it says whole numbers and their opposites. Well, 0 doesn't have an opposite, but it is a whole number. So numbers like this is where you're first going to see negative numbers. So maybe, now this is going to go on forever this way, but negative 4, negative 3, negative 2, negative 1. 0 is an integer. 1, 2, 3, 4. So at this point still, we have no fractions or decimals. But the one thing I want to clarify though, let's say you have 16 over 4. Well, that value is 4. So yes, that is a natural number. It's a whole number. It's an integer. So, but we don't have any simplified fractions or other decimals. Okay, rational numbers. Rational numbers are all of these, and by definition, it's a ratio. So it's a ratio of two integers. I know that might not, might not make sense right now, but I'll show you. Integers. A ratio of two integers. So if it's written as a fraction, so for example, 1/2 is a rational number. 1's an integer, 2's an integer. So it's a ratio, which means division. Okay, let's say it's 3 halves. It doesn't have to, that's fine. That is a ratio of integers. 3 and 2 are rational numbers, so it's a ratio. If it's written as a decimal, now if they're written as decimals, the decimal will either terminate or repeat. So for example, if we have terminating decimals means it ends, it stops, it terminates. So think about the terminator. So it stops here at 5/10. Repeating, maybe 3/10 repeating. If it's written as a decimal that terminates or repeats is a rational number. Okay? Now, irrational. And you learn this in ELA, that prefix means not. So think about it being not rational, meaning they cannot be written as a ratio of two integers. So the numbers cannot be written as a ratio of two integers. And then as a decimal, it doesn't terminate or repeat. It goes on forever. Goes on forever. Okay, so for example, if it's written like this as a decimal, 3, 4, 5, point. If you see this, like the ellipsis that you guys told me about in English, that means it goes on forever. It doesn't terminate, it doesn't repeat. Okay, so that is an irrational number. The most famous irrational number, you guessed it, is pi. Another one you're going to learn later on is e. And you're going to learn that later, but you don't have to have that now. But so pi. Another one, square root of 12. If any non-perfect square, the square root of that is going to be irrational. There's no whole number times itself that gives you 12. Okay? Square root of 3 is an irrational number. Okay? Real numbers. Real numbers are all of these. Everything you actually know right now, for all the numbers that you know at this point, are all real numbers. I used to joke and say, well, are there fake numbers? But yes, there are imaginary numbers, which you'll learn in Algebra 2. But the real numbers, all of the previous numbers consist of real numbers. So at this point, let me think of what I want to say. All the previous subsets. So when you get to Algebra 2, you will find out what we call imaginary numbers. But right now, everything that you know are actually real numbers. Okay, so what we're going to do on this side, so really the real number system, this is like everything that you know is going to be in the real number system. Now, we're going to look at natural numbers. So for examples, natural numbers, remember, are 1, 2, 3. It's your counting numbers. Okay? Whole numbers. Remember, the only difference between natural and whole is that one digit, and that's 0. So it's the exact same. Now, these go on forever, so I can pick 9,922. That's a natural number. That's a whole number. Now, if it's natural, it's also whole. If it's natural, it's whole. It's also an integer. So integers, this is where your negatives start. So -3, -2, -1. Remember, by definition, it's whole number and their opposites. That's why 0 is an integer, because the definition of whole numbers and their opposites. Rational numbers, all of these are rational numbers, but now here's where we can have fractions that can't reduce down. Let's say we have 6/5. You can have an improper fraction, that's fine. We can have, as a decimal, it terminates or repeats. So let's say it's 3 6/10. Let's say it's 1 or 1600, so just the 6 repeating. It's a ratio of two integers. Okay. Now, irrational numbers. Of course, the most famous one is pi. Square root of, let's say, 2. Square root of 15. As long as these are not perfect squares. And remember your perfect squares. You can look at your yellow perfect squares chart. If there's no whole number times this number, it's an irrational number. Okay, so that's the video notes of the real number system. You are then probably going to watch a second video about how to fill out this chart. Actually, no, I'm going to go ahead and do it right now. So what this is just practicing identifying the real number system. So practice number 1. Now, I'm not going to do all this for you, but I'm going to show you. Now, put the X in appropriate cells that indicate which set each number belongs. So 18/6. Now, first of all, that is a ratio of integers, 18 and 6. So we know for a fact it's a rational number. And then also, look at the value of that. 18 divided by 6 is 3. If you look back at your notes, okay, so 3 is a natural number because it's like a counting number. It's a whole. It's an integer. Irrational, it cannot be rational and irrational at the same time. So do not mark both of these at the same time. But then also it's a real. Okay, now go to the next one, 4 3/10. Well, what type of decimal is that? Well, it's a terminating, it ends at the terminating decimal, so it is a rational number. It's not an integer, because that's whole numbers, naturals, not any of these. It is a real number. Square root of 25. What's the square root of 25? That value is 5. So that is going to be a natural, whole, integer, rational, and real. Okay? Let's jump over here for a second. Let me show you something. Let's jump over to maybe -4. Now, -4. Negatives, when you're a little kid, you don't learn about negatives, so don't put it's not natural, it's not whole. It is an integer, it is rational, and it is real. You're going to notice something real quick here. So I want you to practice that. And on the back, if you got this set, you should also have practice 2. So I want you to practice identifying those subsets.